Okay, so if you guys do me a favor, go to chapter 3. Chapter 3 talks about busways. Busways as in feeder busways and plug-in busways. Yesterday, Jim talked about busways. I want to highlight a few things, guys, for you. If I remember right, I want to guys remind you of the actual sizes of busways that we're going to be using in our calculation, which is in, where's my busways? Here you go. If you guys go to 313, section 313, that's all the busway sizes that we have. I thought to take this opportunity to size the busway for you guys that we did. If you, based on my calculation, I'm sure based on your calculation, here's what we're going to have, guys. We're going to have a feeder busway. We're going to have a feeder busway, a 1,000 amp feeder busway. And I want to remind you, Brad, my friend, that you need an overcome protection device 1,000 amp. So here's a typical busway, 1,000 amp coming from the switchgear. Very typical to your project, guys. A 1,000 amp busway feeder. And this 1,000 amp, guys, is going to split, as you can see, all the way. And then you're going to go to plug-in busways. And I'm going to highlight the plug-in busways in here. And this is typical what you guys are going to be doing. But I want to remind you of a few things. This is my feeder busway coming in. I want to remind you that you need to be sizing for your friend Chad an overcome protection device. This will be 225 amp. So if you guys look, the smallest plug-in busway that you can get, Brad, is 225. It's not worth, Brooks, my friend, it's not worth to put anything less than 225. So when you guys start laying out your power, which you will be for me, when you lay out your power, basically here's what your layout of your power is going to be. Your feeder is going to be 1,000, and you plug in, each one of them is going to be 225. So this will be a 225 amp, 225 amp, 225 amp, and 225 amp, 225 amp, 225 amp, and 225 amp.
What's the max you can go with on the plugins?
The plugins, you can go from here all the way. Well, he said, remember what he said last time? Technically, which is really good. That's what having the industry. He said you don't want to go more than 800 plug-in. Based on this, you can go all the way up to 4,000. They'll make a 4,000. It's not a good idea to go more than 800. Did you guys hear what he said yesterday? 800 is a really nice cutoff for a plug-in. In our case, guys, the plug-in is going to be 225 amps. 225 amps. I want to remind you guys, the bus will be also 225 amps. And Jim, my friend, the overcome protection device. Can you guys see that overcome protection device? Each one of them is going to have an overcome protection device. So it's going to be also what? What do you guys think the overcome protection device is going to be? 225. So regardless of your calculation, Spencer, regardless of your calculation, please use 225 amp as your minimum on the plugins in our building. And the feeder is going to be based on my calculation. If you guys came up with something different, based on my calculation, the two buses that we're going to have is going to be 1,000 amp.
So
1,000 amp.
If you were to run 800 out there, you'd have to put 800 plus on it. It's just.
If you are to put 800 overcome protection device here, yes, yeah, this has to be 800. Absolutely. The best thing, guys, when it comes to plug-in busways is match the overcome protection device to the plug-in size, if you can, to the best of your ability. So this is very similar. I like this, guys, because this basically is going to show exactly what we're going to be doing in our project. All your plugins, did you guys hear me? 225 amps. Based, anybody can tell me why do they have, well, we know why we have 225 amp here, 225 amp here, because we're going from 1,000. Every time you go from a higher amp to a lower amp, you have to have an overcome protection device, as we all know. Any question, guys? This is very similar, extremely similar to what you guys are going to be doing. Okay, questions, guys, about plugin. How are you going to do it in our project, guys? We have a family that's called busways. You guys are going to grab it and extend it and show it. It looks exactly like this as a Revit family. Very easy to use. We use it last time, perfect. Then what I want you guys to do is then you put disconnects next to them in Revit. This is for us, Revit. Here's my disconnect, and then we're going to stop at the disconnect level, guys, Revit-wise. Revit-wise, we're going to stop at the disconnect level. So you're going to go assign a load for this in Revit. You're going to assign, you know how to grab a disconnect, just physically, mechanically put it right next to the busway in Revit, and then assign a load for it. So if this disconnect was in Revit, you go put like 15 amps. So that will be disconnect for 15, load on it is going to be a 15 amp disconnect. Load on it, the load will be 15 amp. And then, I'm talking Revit here, you're going to assign the load to the disconnect, and then you're going to wire, later on guys, you're going to circuit the disconnect to the busway, to the plug-in busway, and the plug-in busway to the feeder busway. Did you guys hear me? In Revit, when we do in Revit, first you're going to draw this. We have a family for all of this stuff. Second, you need to put an overcome protection device, which is right here. It's going to look something like this, disconnects. Basically, overcome protection device right next to these, the main for each one of these, right? That's easy to do in Revit. A disconnect with an overcome protection device. Then you're going to put disconnects for the equipment, and the disconnect is going to have an amp load on it, and you're going to circuit the disconnect to the plug-in 225. Each one of these disconnects will be circuited to the plug-in, and then the plug-in will be circuited to the feeder busway, the 1000. So the 1000 and the plug-in is going to have a distribution system. You know how to make it's like a panel, assign distribution system for it. And then the 1000 amp will be circuited to the switchgear. Did you guys see that? How circuiting in Revit we're going to do it? We start with the disconnect circuit, the disconnect to the plug-in, then the plug-in to the 1000 amp feeder, the 1000 amp feeder to the switchgear. Any question guys about circuiting in Revit? Very easy, straightforward, Revit-wise anyway.
We're going to circuit that to the mechanical equipment then?
These buses, based on our requirement, they're coming directly from the switchgear.
Okay. So we're not going to circuit it from the disconnect to the mechanical equipment. It's going to be.
Yeah. You mean? Am I going to circuit the equipment to the disconnect?
If that disconnect goes to your air handling unit, are you going to circuit it to the air handling unit, or are you just going to circuit it to the panel?
Thank you. First, I'm talking about on equipment. So the air handling unit is not part of the discussion.
Okay.
I'm coming to this. I'm coming to that one. Very good point. I'm talking here, guys, of the owner equipment. These are the welders and all this good stuff. For the welders, I don't want you to go grab a welder, guys, and put it there and circuit it. We're gonna put a disconnect. We're gonna call this disconnect a welder based on the acronyms. Give it a load and circuit it to the busway. The owner. This is for the owner equipment list. Everybody get that one? Owner equipment list, just a disconnect. Mechanical equipment, you're right. The mechanical equipment, the air handling unit, the pumps, and all this good stuff, these will be fed directly from two panels. One of them is MP1, MP2. For these ones, guys, if what we did in the past, either you drop an air handling unit with the same size like the one I gave you and circuit it directly, or it wouldn't hurt my feeling to throw again a disconnect for a pump, just a disconnect, call it pump number P-1, and give it a load and circuit that disconnect to the, in this case, MP1 or MP2. So, any question guys about the circuiting?
Do you want us to put plugs from the machines rated on?
No. The question is, am I going to go down to the SO cord and the plug-in? No. You can if you want to, but going like what you're saying is, here's my machine right here. Am I going to show the cable coming from it right in here? This is going to be SO cord. No, I don't want you guys to go down to the SO cord. Any question guys about the busway? This is basically a typical busway. I want to bring to your attention guys a few things. The hardware that comes with it. Look at this T. We have a hardware that comes with it. If you're a project manager, that means a whole lot to you guys, because there's a hardware that we can have a hardware that so many hardwares. Long story short, and the box that you can put a circuit breaker that comes with it. So there's a box here attached to the feeder. Inside this box, you're gonna have a circuit breaker that feeds a plug-in.
Do you have that in the Revit family?
I don't think we have the T's. What we did in the past, we just attach them physically, mechanically, just make them connected. That looks like they're attached. I don't think we have this fitting here, if I remember right.
But the disconnect.
The disconnects are there. Yeah, disconnects are there. Any question, guys, about the busways? What's his name? Jim did a great job yesterday, guys. Busways, concentration of load. If each one of you is a machine, I want to feed each one of you with an SO cord. It will be a great application for a busway right in the middle, and cords are coming everywhere. Any question about the busways? So that's really what I want to mention about the busway. This particular one. The second thing I'm gonna do, guys. There's a lot of hardware. I don't know if you guys noticed what he said yesterday. How now they sandwich all these buses for all the phases and the neutral all together, and they bolt them with one bolt. That was really interesting. Instead of multiple bolts, they put them all together. The three phase, so phase A can have 6 bus bars, and phase B another 6, and phase C another 6, and the neutral another 6. All of them are sandwiched together, and they're all tied with one bolt. I thought that was really, if you guys paid attention to that one, what he was saying yesterday, I thought it was really cool. There's a couple of hardware. Look at it. If you're a project manager, you probably have to get used to this. Busways, guys, it's not something that you're going to cut in the field and cut it and let's go assemble it. It comes with a lot of hardware that can get you left hand, edgewise, T, and all of the good stuff. Reviewing them when you're on. Here's a cross. Look at this flat-wise cross and edgewise cross. And you can imagine how it's going flat or going, depending on the direction that you're going to go. So these guys are fittings. The hardest thing, DJ, and I'm sure a lot of you guys, if you wear things, the hardest thing in the electrical field is to keep a track of the hardware. If you haven't done this, you basically have to pay a little bit of attention to the hardware. So please check the hardware that comes with it, especially if you're going to be a project manager working with it. Yes.
How can you bolt all the phases together? Isn't that the same as
Shorting them?
short? Yeah.
There's an insulation. Yeah, there's the hole that goes through them is fully insulated. Yeah. But that is really cool. That's exactly what you say. How are you going to bolt all these together and you still? It's really cool. The insulation that they come with them is unreal. It always amazes me. Okay, here's a cross section, guys, of a feeder. I want to bring to your attention, guys. This is my feeder coming in here. Oops. Look at how this feeder. Look how they do it. This is my feeder coming in here. And look at the circuit breaker, guys. Coming circuit breaker 1, circuit breaker 2. This is where 225 amp and another 225 amp, right? And then going, feeding different dots. Can you guys see that? So, and this would be my 1000 amp. Does that make sense? 1000 amp coming in with a box that you can put 2 circuit breakers in it. You can put 1 or 2. Look how nice they put 2 here. And they wire the box. Look how they, from the line side of every switch, they wire them. And then they went with 225 this way or 225 the other way. It doesn't have to be 225, guys. It could be 400, 800 amp. But having to be, but this is, I thought this is a good visual, showing the connections. Any question, guys, about this? We don't have to know that. It's really nice. As a project manager, it makes you appreciate it. So that's what I wanted. This is what I wanted to show you guys. This is a complete system with busway. You can, I always emphasize this, with busways, code-wise, you can go through walls. A lot of people don't understand that. You can go through walls. The only restriction, Brooks, to go through a wall is you have the section that goes through the wall cannot have a plug-in. Meaning if you have a plug-in, you can't put the plug-in right through the wall. Does that make sense? You have to move it, the section that goes through the wall have to be non-plugged in part. That's the only section. You can go through the wall. DJ, you can actually tab and feed a conduit from it. You have a box and tab and go to another system, wiring system. You can feed a panel, believe it or not, you can bring it all the way down to the panel, or tab, or the most important things is the plug-in, guys, which is you plug-in machines. That's why we have it. In-tab, switch box, you name it. Here's why we use them. Really, the main use for them is here's my machine over here and tie it to here. That's the main use for them. Plug in busway, but you can tap into it with a cable. You can feed a panel. You can go from a switch gear into an MCC, like it shows over here. You can make the whole wiring system, guys, a busway wiring system. It doesn't make a lot of sense feeder-wise, my opinion, is if you're to pull a feeder, it doesn't make sense to pull a feeder busway less than 1000 amps. It just doesn't make sense. A feeder, a plug-in, 225, no problem. Plug-ins are good. Plug-ins, it makes a lot of sense, Mr. Irbab, to do them if you have a concentration of load. That's where the plug-in, concentration of load in one area. But feeder-wise, 1000 amp, it makes a lot of sense to use busways to feed, to move the amount of power in. So this is really I thought this is really one of the best things in this chapter, 3D view of all the bus in.
What would you do if you had to go through a firewall? You know, if they can.
Yeah, you have to
They
copy
seal it
with
up.
fire-rated wall.
They can.
Fire-rated wall, yep. It's like a conduit. What do you do when you go through a conduit? Same thing. As long as you don't have a plug-in right through, can you guys see what I mean right here? Plug in right through the wall. You don't want to have plug-in right through the wall. Any question, guys, about this? Any question? So I thought these are the most important things. There's a few things about the hardware. Please read them on your own. I don't want to talk about the... if you're a project manager, this is a perfect thing for you. You guys are going to be ordering. If you're an engineer, care less about what I'm saying here. If you're working in engineering firms, if you're a project manager, a big deal. You need a rod hangers to hang them. Look at that. The hardware that comes, guys, to hang them is a big deal. These are very heavy equipment. You have a strap hangers like this, and I don't claim to be an expert on these, a bracket hanger, or you can have a suspended wire to hang them, as you guys can see. Another bracket from here. So these are all hardwares that comes to hang this in huge load. As Jim said yesterday, guys, these are heavy equipment. If you are, Brad, if you are to work on a project that has a busway, the first thing you need to do, you're going to talk to the structural engineer. The first thing. Because you're going to hang these heavy equipment, guys, 2,000, 3,000 amp bus duct from the structure of the building. Would the structure handle a 4,000 or 3,000 amp bus ducts hanging from it? That's a question you have to talk to the structural engineer. You can't just go hang a heavy load directly from the ceiling if that structure is not rated. Look at the structure. All this, guys, is mechanical, physical load on these trusses. You have at least to consult with the structural engineer, load-wise. At least mention that to them. If you have, especially if you have a 2,000, 3,000, 4,000 amp busway that you need to hang from the ceiling. The rest of it is hardware. The rest of it is hardware.
Probably use their traffic on it. If you're talking 3,000 or 4,000, you're not going to use a hanger.
But if,
It's too heavy. You're not going to use 4,000.
yeah, but whatever you use, you're going to use the structure to hang it, right?
I'm completely saying.
Yeah.
I'm just saying, you're talking for this purpose.
Yeah.
There's only one there that's going to work.
Yeah.
It's too heavy, and that's one of them.
Yeah. Say this was a 4,000 amp and going right across. Physically, mechanically, it's held by the structure of the building. So
Right, but the other.
this one,
Mounting it aren't going to work.
these are not going to work,
No,
as you say?
it's too heavy.
Too heavy for that one. I don't claim to be an expert in the hardware that goes with them, but I know one thing. If you're going to be hanging them, especially 4,000 amp switchgear, it's better talk to the structural engineers. Any question, guys? I know there is a question on the test, just FYI, about the type of hangers that you use. So they're right here in front of you. Strap hangers, there's rod hangers, and so forth. Any question, guys? Any question, my friend? The last picture that I have for you is this is how you tie your cables. So Spencer, my friend, you're going to bring your phase A, tie it to this lug, and this is phase B. Oops, why do I need this one? I need to color code them. This is phase B, and the last one obviously is going to be phase C. Lugs, you can see how they're bolted to the buses right here. I don't know if you guys can see that. These are not something that you're going to go cut in the field and reassemble and add to it. It comes all custom training, custom 10-foot section. If you are guys to build you need a 3-foot section because you're going against the wall, then you have to go ask to get you a 3-foot section of this busway because whatever reason that you need to do. Any question, my friends? That's really what I want you guys to know about. I don't know if you remember. My friend Jim yesterday said when you guys have a plug-in, they normally have every 24 inches, they have a plug where you can plug holes where you can plug the 3-phase and the neutral, 24 inches. So really you don't have problem, Mr. About plugging in machines and changing the direction and so forth for them. You have enough ample amount of things to do. I want to remind you one last thing, guys, before I unless anybody has any question about it. I want to remind you that these could be right here, capacitor plug. You can have anything you want from it. Let's go to the plugs directly. Okay, here you go, the plugs. When I have a plug right here, your options, guys, two things. Either you have a switch with a fuse. A lot of people, guys, can have a switch fuse, or it looks exactly the same, or circuit breaker. If it's a switch and a fuse, I just want to remind you guys, you use with 30 amps disconnects, and you go to 60 amps and 100 amps. These are the disconnect sizes, and you have the disconnect sizes right in here. Size of disconnects in page 312 if you're using a fuses. So we'll make sure you'll follow the 30 amp, 60 amp, 100 amp, and then inside them you can put different fuses. So up to 30 amps, up to 30 amp fuses, I can put them in a 30 amp disconnect switch. Or you can use circuit breakers. If you're using a circuit breaker, guys, then you guys go 15 amp. What is the next? 20 amp, 25 amp, 30 amp, and so forth. So that's just a quick reminder. For us, use circuit breakers when we're not going to size them to speak, but let's assume we're using a circuit breaker. So when you guys size, so if you have a welder and the welder is 5 amps, you multiply 1.25 times 5, get you less than 15 amps. A 15 amps, 15 amp 3-phase circuit breaker. Done. It's going to be in an enclosure, and it's going to have a handle where you can shut that circuit breaker down and lock it in the open position. Any question, guys, about busways? Any question about busways? I'm going to jump over the panel boards and go to chapter 5. I'll get back to chapter 4. I'm going to go to, this is chapter 3, really nice. I don't know if you guys have noticed that the book is really nice. I hope it's nice. Easy way. I'm going to go directly jump to chapter 5 because of one reason. Chapter 5, guys, talk about trolley busways. So it's continuation of what we're doing. So if I want to say one little thing, guys, about this this time is, number one, as feeder busway, we know what a feeder busway, take a huge chunk of current from point A to point B. Plug-in busway allow you to plug in multiple loads concentrated in one area. This one is a trolley busway. Trolley busways, guys, the main reason for having a trolley busway is to be able to move the load along a predetermined path. Really, this is the only reason why would you use it. Size-wise, I always use the same sizes of Brooks that we have in there. So 225 amp is the smallest you can get. In our project, Jim, my friend, we do not have a trolley busway, but trolley busway, Mr. Bev allows you to move the load like a drill. You move the drill as you move through and work on the machine. So it's really the most important things. It comes with a lot of hardwares. I want to go directly to, you can guys go read through the hardwares, and I want to go to one thing. Here's how, so we have a busway, and in the busway, guys, trolley busway, here's the box that you can attach a load to it. So you come over here, and this is my trolley EY, trolley busway, right? EY, trolley busway. So the idea, guys, is you drag that little box inside the box. You're going to see, guys, later on, inside this box there is a fuse and a plug, and your machines are plugged in it. Your cable, SO cable is plugged into it. You drag it and you move it with the load. So if I have a machine right in here, I wire it. Here's my plug. It's plugged into this plug, and out of this plug, my friend, I need to fuse it. Oops, this is my fuse, and from here it's tied somehow to the busway here, and it moves with it. There's a nicer picture of that one, but I want to bring to attention, guys, there's an SO cord coming down. This is my SO cord coming to feed the machine. There's a plug. Why do you think we have a plug here? You don't have to have a plug, but why do you think you have a plug? Disconnect, thank you. Otherwise, if you don't have a plug, you have to have a disconnect, because that's a machine. You need a disconnect for the machine. So the plug acts as your disconnect. You can unplug the machine is dead. if you were to maintain the machine. And then a fuse, why do we think we have a fuse? This is not so core. If I have a number at 12, 3 conductors number 12, I need a 20 amp fuse because this one happened to be 225 amp. So from 225 amp, I'm tapping, feeding a 20 amp fuse, out of the fuse a receptacle, out of the receptacle plug that goes all the way to feed the machine. What's the advantage of this? You can drag that baby along a predetermined path, so allows you to do a function, build a car, butcher a cow, or do whatever you want to do. I don't know if we're going to see, I can't remember if Boston Scientific has them, guys, but I'm sure you've seen them around if in the manufacturing. I think Cummins have them when we go to Cummins. You can drag and work on the machine, and you move it around, and you go all around. And it doesn't have to be straight, guys. They make them in a loop that you can loop around the whole. You have to have a right angle, give it the right ample amount of angle so you can loop around and go to different areas. Really, this is mainly manufacturing. So Spencer, what would you specify something like this in an area that they're working on machines all the time, and the load change? If I'm working on this piece of equipment right here, and the equipment moves, and I need to follow the movement of the equipment, that would be a good idea. That with the same tool to continue on the assembly line is a good example. Working in here, and you're moving with assembly line and doing certain things. Okay. Oh, sorry. That one. Come on, buddy. I want to show, there you go. So we got that one. I have a cross section of that one that I thought that was really cool. Trolley bus, and they're talking about the trolley busways in the project. You guys can, there you go. I don't know if I have that one. Come on, buddy. It's loading. I don't know what's going on with that one. Froze on me. There you go. This is exactly what I want. Okay, this is, guys, a more really nice view of it. I want you to look at the contacts. These are where you get your phases connected, the 3-phase. The trolley has wheels that you can move. The trolley, of course, you have to have a wheel. You have to have contact to get connected to the power. And here's the fuse that we talked about, and here's the plug, the receptacle, the plug as a disconnect, an SO cord, all the way to the machines. All the way to the machine. I want to bring to attention, guys, all the plugs that they use with them as lockable type plugs. And you can imagine why. These are not plug in, they're plug and lock. Locking type receptacles and plugs. Really cool. And because they have people like DJ and they want to have rest all the time and unionize electricians and all this stuff, they have a tool hanger so you can hang your tools here and go have a break or and so forth. So really, this is, if you are to work on a project like this, the first thing I would do, guys, is there will be manufacturing engineers, Brooks, on site. They're the ones who, I have no idea what this drill is going to be doing, or this piece of equipment is doing. So they'll tell you what type of equipment, and between you and the structure, the manufacturing engineer, you decide the right application for your area. The right application for your area. Okay. Any question, guys? Don't know where my computer is getting out of whack here. Did you do anything with the network, Mr. Erbab? Okay, so if you guys, it's not firing here. There's a lot of pictures about the hardware. Read them, FYI. We're not electricians, so to speak. If you're even electrician, guys, I teach apprenticeship classes. Very few people get the honor of installing a bus system, a trolley busway. A trolley busway is not a system that you install every day. You really have to have a manufacturing floor to work on it. So there's a few hardware that comes with it. Support. Please read that one on your own. I want to mention, I was hoping my mind would fire here. Oh, there you go. Okay. They have the strain relief cord grip. If you guys look at them in your book, strain relief cord grip. The most important things, guys, as you hang the SO cord, the last thing you want to do is the SO cord load will be completely connected to the lugs, the electrical lugs. So what do they have? They have a grip that attached to the cord and hold the physical mechanical weight of the cord. So, and these, believe it or not, there's a whole science around it, guys. They have specification. Look at that, 40-pound categories, and it carries certain amount of loads. So, just pay attention to this one. Thanks God, we don't specify this one. Usually an SO cord, guys, you come with an SO cord, and there's specification that this SO cord goes with this grip. A lot of grip type that you can use, guys. If you look at and this is FYI, please, you don't have to worry too much about it. Look at the grips, that different type of grips that you guys can use for different type of applications. Different type of grips for different type of applications. The strain relief grip, everybody knows why the strain relief grip, because if you have a cord, you don't want the physical mechanical load to be supported by the lugs, the electrical lugs. Otherwise, what happens if you don't have it, guys? Then the cord is the lugs. The electrical lugs are going to be pulled apart, and you're going to have arcing and sparking, and that's not what you want in your building. In our project, guys, we have three plug-in busways. Look at them. We if you guys remember, we reviewed them. 225 amp is a good size for them. Good starting size. Though you can. One thing I want to mention, guys, if this is 225 amp and the load on it, the equipment that's connected to it, if the equipment that's connected to it, this is the size, the load, say suppose the load was 94 amps. I calculated the load on this one and it's 94 amps. The smallest that I can go to is 225 amps. So here's a question that you're going to ask yourself: should I go? So I plug it in. I need a cable that tied to it, and I need to take it all the way to overcome protection device in the panel, right? This has to be fed from somewhere. So I need a cord to come and feed it, and I need an overcome protection device. In a case like this, guys, if your load is no 94 and the smallest that you can buy is 225 amp, it makes a lot of sense to make the cable 100 amp and the overcome protection device 100 amp. Is that okay? A 100 amp overcome protection device feeding a 100 amp cable to feed a 225 amp plug-in or trolley busway. That's okay. That's fine. So if you load, my point, if you know your load is small, but you can't, this is the smallest that you can buy, 225 amp, then it might be a good, especially with a difference like this. Look at that, 225 amp to 100 amp. That's almost double. So it might be a good idea to size it based on the overcome protection device. The next overcome protection device is 100, and the cable is 100. Call it a day. It's like panels, guys. They don't make panels for every overcome protection device. So if they make panel 225 amp. What if your load is 150? Well, I can put 100. If your load is less than 150 or less, you put 150 amp circuit breaker in a 225 amp panel. That's okay, no problem. Who cares? Because that will reduce the size of the conductors and of course the price of the project. Look at the alternative. What's the alternative, guys? The alternative is 225 amp panel, expensive, tied to here, and this cable 225 amp cable. I can do that, right? I can do with 225 amp circuit breaker feeding a 225 amp cable that feeds a plug-in, a feeder, well, a plug-in or a trolley busway. In a case like this, I will vote for the 100 amp feeder and overcome protection device. I just want you to be aware of this one. Any question, guys, about this? So you don't have to match the size of the panel. You don't have to match the size of the panel or the size of the overcome protection device, of the busway, I mean. Like for example, you have going from 225. If you guys want to go to 225, the next standard is 400. So what if my load is 300 amps? I know my load is 300 amps. So I can't use a 225 amp plug-in. I have to use a 400 amp plug-in, but I can fuse it or circuit breaker it at 300 amps, which means I can carry cables for 300 amps, which is cheaper equipment. Value engineering. Yeah, you can do that one if you want to cut cost. Any questions guys about the trolley busways? Any questions about the trolley busways? Everybody knows how to size them. Brad, right? We know how to size them. If they were feeding motors, we take the largest motor multiplied by 1.25 plus all the other motors, and we go to this cable and we pick the size that can give us this amount of amps, right? Like we did with Chad, and we put the overcomputation device, your option. If the size, as I said, if your load, look how had this load been, guys, let's just throw 201 amps. Had this load been 201 amps, it'll make a lot of sense, guys, to make the cable 225 amp and the overcomputation device 225. It all goes by what's the load that's fed from this piece of equipment. What's the load that's fed from this piece of equipment? And it's really judgment. You can have a load 94 and decide to use 25, 25, 25. 225, 225, 225. That's okay. So, but you can save the customer some money, and some can argue, well, what if they add load in the future? And so, personally, if the difference is twice like this, I wouldn't hesitate. Like this one, 94 amp, and the next is 225. That's double. I wouldn't hesitate to size based on the load. So, doesn't want to go. Am I right to assume that everybody guys knows how to size trolley busways, plug-in busways, and feeder busways? Size them, right? That's all we do as a designers. I understand what they do. That's it. The hardware, guys, don't sweat it too hard if you don't know every single screw and fittings that fits with it. That's, if you're an installer, that will come. We're not installer, but it comes with experience.
How expensive is one of those trolley? Just the trolley part that actually moves on the track.
Are you in the money, man? I don't know. I've never installed it. I really don't know. I can throw a 10-foot section and say maybe $5,000. If I would to guess, I would say $5,000 for a trolley busway with the hardware that comes with it, 2 devices and so forth. They're definitely more expensive than plug-in because now you have moving objects and you have moving objects while energized. DJ, want to research this one online and see what the price of these babies are going for? The last thing I want to do, guys, today with you, I'll talk about chapter number 4, which is panel boards. I wanted to do a few things about panel boards. I don't know if you guys remember what Jim said yesterday. I think he did a good presentation about the difference between load centers, panel boards, switchboards, and switch gears. These are very, very important, distinct things. When my computer line up, I'm going to write just 3 things, guys, about what's a load center, just a few things. What is a panel board? Just to emphasize what Jim said. What's a switchboard and what's a switch gear? And then we'll talk slightly, and I'm not going to talk as much as he did, about the MCC, the advantage of using an MCC. Oh dear. Wow. It's getting nuts, my computer.
What about what is what? You're just going to go through pretty.
Give me a second, yeah, in a second here. You guys will take a few minutes break, and I'll go to the restroom here while my computer loads up. Spencer, Holly's not coming. Is she here?
No,
Okay. Female.
it's fine.
What's going on here?
See, you've learned. They have.
So, what did you say about you can't hang this switch gear from?
Well,
It wasn't.
you're talking a 4,000
Like,
amp.
yeah, the one.
bar and
Yeah.
Trapezoid.
Yeah. You
That's
can't
the
have
only
enough.
one of those example stuff.
So how do you do it? You put brackets all the way
Probably
down.
half-inch rod.
Yeah.
Big strut or steel.
Okay.
Most likely steel.
Okay. So
Steel
bigger,
end
thicker
plates,
rods. That's what.
Half-inch probably.
Okay.
That's what your structural engineer would probably spec for you.
Yeah.
Because it's 4,000
It's a heavy.
bus duct is getting,
Heavy
you ain't
equipment.
lifting that up by yourself.
Yeah. No, you need a left and for
Yeah,
the sections.
so
Yeah.
that's what I was getting at, is that trapezoid way is probably the only way it's gonna handle it.
Okay.
It's just too heavy.
Okay.
You're not just gonna be hanging a piece of 3/8 rod.
Okay. Can I have your attention, my friends?
Oh.
This is. I'm going to summarize everything that Jim said in one slide yesterday. And Jim is an expert, guys, but the manufacturers, Eric, they tend to go deep into the structure and all this good stuff. This is how I understand it from a consulting engineer. If you guys want Chad's opinion, if you don't want it, you have to stuck with your instructor's opinion anyway. Let me just say a load center. Load center, very few things, guys. Load centers, when you think load center, always think up to 60 amps all the way to 400 amps, if even, up to 400 amps. That's limitation, Eric, there's limitation on the amps. Big deal, limitation on the amps. Number two, think residential, always. Think residential, always, when you think load centers. Think 240, 120 single phase, and some 281, 123 phase apartment buildings. That's where you're going to see them, guys. 281, 123 phase apartment buildings. They will have a 400 amp panel load center. Jim talked about the difference, guys. It's a smaller panel. It fits between the studs. That's really what they call a load center. It fits between a 16-inch stud and a 3.5-inch deep. So that's what the load center is. Easy to work with, plug in, and so forth. Any question, guys, about the load center? So Spencer, if you're an engineer working for engineering firms, don't even mention the word load center. If you have a residential building, yeah, it's a cheaper product. You can buy 100 amp, guys, load center for $80. 100 amp panel probably will run you $300 because it's bigger, bulkier, different type of arrangement. Any question, guys, about the load center? That's personally how I understand the load center. Any question about the load center? You can have them surface mounted or recessed like everything else. In a wall. All these need a wall or need a structure. You can mount them on you need a structure to mount them against or in. Any question, guys, about the load center? So think residential when you think load center. And 99% of the time, Spencer, think single phase even. Think single phase. Panel boards. I don't know if you guys remember what my friend Jim said yesterday. Panel boards, they can go all the way up to 1200 amps.
He said 600 yesterday.
Higher than, I thought 1200 amps.
I was
You have 600 amps?
That's
Oh,
power panel, your power panel.
the power panels. So panel boards, guys, the way I understand the panel boards, and there's give or take, we're not going to fight over that one. Panel boards, guys, the way I personally understand the panel boards, they need a wall to mount them against. That's what a panel board is. It really needs a wall to throw that panel board against it. So between roughly 125 to 1200 amp, you can buy a panel. It looks like that. These racks there, throw them against the wall, right? And that will be. It has bigger circuit breakers. You can have with 1200 amp, you can have a 500 amp feeder from it. So 125 all the way to 1200 amp. Where would you use them, guys? Commercial and industrial. Commercial, industrial. What voltages? The most common voltages for these is 28120, 48277, 482 277. This should be three-phase. That's mostly the most common. A lot of commercial buildings, guys, have panel boards. Panel boards that can go all the way to 1200 amps. 1200 amps at 480 is a lot of power. So don't think it's nothing. 1200 amp at 480 277 is a lot of power. So that you can use it as a main. What happens is you can use a panel like this as a main, guys, and then a sub panel like receptacle panels. In our project, Brad, everything, all the panels that we're going to have is going to be panel boards. Some of them are going to be 225 amp. Some of them, like the mechanical equipment, when we size the mechanical equipment, guys, if you remember, we came up close to an 800 amp panel. So we're going to have an 800 amp panel board thrown in the wall with big circuit breakers coming out of it, a panel board. So in the project that we have, guys, every single panel that we're going to have, lighting panel, receptacle panel, we have also the mechanical panels, the two of them. These are going to be panel boards because you're going to be within the 125 all the way to 1200 amp. Not the main though. We're not talking about the main. Okay, so that's where our project, almost all the stuff that you guys are going to be doing are here. I want to remind you, if you guys forgot, that the standard sizes of panel boards are located right in here. So we have panel boards, according to this guy, the panel boards goes all the way to 600 amp. And these are what he called them lighting panel boards. And then switch gears and switch boards goes all the way to on the other side here, which is 312 and 330. Any question guys about the panel board? So this is where we are. Camille, my friend, this is us. 125 all the way to 1200 amp. In our system, most of them are going to be 480, 277, except one panel. It's going to be 28120. Anybody remember that panel? Receptacle panel. Receptacle panel. If you were to design this system in Europe, Brad, not that you're so excited about Europe, you only need one voltage. 380/222, one panel, receptacles at 382/22, lights 382/22, mechanical equipment 382/22. So you don't have 28120. That's kind of the advantage of having a higher voltage, but it is what it is. The utilization voltage that we use, guys, the general purpose receptacle is 120. Is kind of a pain in the butt, so you have to have a panel for it. Okay, so that's the panel boards. Switchboards, guys, the way I understand them, and please research and find it differently, it makes a lot of sense to make them from 1000 amp to 4000 amps. Switchboards, guys, I want to summarize it in one thing. It's a big fridge sitting right in the middle of a room. Standalone structure. That's the only major difference between switchboard, switch gears in one side and panels and load centers in the other side. Panels and load centers, guys, you have to support them against the wall for the most part. Switch gears, switchboards, you can put them right in here. They're structurally sound to be supported by their own structure. So they have a structure. And he talked about hanging them from a structure and so forth, but it's standalone. Voltages, guys, these are the voltages, the most common voltages in the US. Now, can I have a 600 volt? Of course, they are 600 volt rated. So you can have a 600 volt if you are using Canadian standards or any other voltages. The most common switch gears that I installed, and a lot of people, 99% of you guys will be using 28120 or 48277 switchboards. Heavy commercial and industrial is a good application for them. You can have circuit breakers inside them or fuses, like he said yesterday. You can have a drought circuit breakers on them too. Or you can have bolted, you know what the drought guys, you draw the circuit breaker out, or you can completely bolt them into the frame. So that's basically the switchboard. Any question guys about switchboard? The key point, Spencer, it's standalone fridge right in the front of the room. When I think of switchboards, guys, I always think of, just imagine big fridge size, 4 of them side by side. That will get you a 4000 amp switch gear or switchboard. Any question, guys, about the switchboards? Any question about the switchboards, my friends? Without getting into the details of the structure and how they build them, standalone, right? They have their own frame. Switch gear and switchboard, guys, if you're looking at them, you wouldn't even know the difference between them. If you look at switch gear and switchboard, they look alike. Switch gear, the same thing. It makes a lot of of sense, guys, to go from 1,000 all the way to 4,000, and they even make 5,000, like he said. The voltages, the same voltages. Where would you use them? In data centers, hospitals, process equipment, anything that the reliability of the system is very important. If you don't want a downtime, if downtime is a big issue for you, switch gear comes to your mind. So what's the difference? Look at this. Here's a 4,000 and here's a 4,000. What's the difference between these? They look alike, right? They look alike. They're drought circuit breakers. One of them is 4,000, the other is 4,000. By the way, price-wise, guys, price-wise, I wish you talked a little about price-wise. If you have a switchgear 4,000 versus switchgear switchboard 4,000, you're looking at least 25 to 30% more money. More money. Why? Because they make the switchgear, guys, to ANSI standards. Where's ANSI? They make it to ANSI standards, and ANSI standards, they insulate everything. They have 3 chambers. The key point for switchgear, 3 chambers. One chamber completely isolated from the second chamber, the third chamber. Chamber 1 for the circuit breaker, chamber 2 for the buses going up and down, and these are completely isolated. And chamber 3, guys, for cables. So from the bottom, you can bring all your cables from the bottom and feed all the buses from the back of the switchgear. And you're talking about close to 72-foot deep switch gear. So these are bigger equipment. Why do they do it this way? If you have a fire in the compartment of the feeder, it will take forever to reach the compartment of the bus because they're completely isolated from each other. And the same thing, if you have a fire and arc and spark, guys, in the circuit breaker, it wouldn't be seen by the buses. The buses wouldn't even see it because they're completely sealed from each other. That's the key point. Who cares? I want you to remember this, and I hope you remember it, guys, when we do short circuit analysis and coordination. This is a major thing for engineers, a 30 cycle. Now, probably a lot of you look at this and say, what the heck are you talking about, Chad? This is this. He didn't mention it yesterday, but this is one of the most important thing about switch gears. The single most important thing about switch gear. It's 30 cycle rated. What does that mean, Chad? This circuit breaker, guys, if you have a short circuit right in any of these branches right now, it's rated for 3 cycles. What's a cycle? 3 cycles, 3/60 seconds in seconds, right? 3 cycles, 3/60. So 1/20th of a second. So this circuit breaker is rated to trip at 1/20th of a second. 1/20th of a second. See how fast that is? If it doesn't trip within 1/20th of a second, you know what happened? Everything here will be burned. That's how they rate them. 3 cycle, all these circuit breakers are rated for 3 cycles. So who cares, Brad, when I do my coordination, I have to take this into consideration, Spencer. Otherwise, if I allow the short circuit to sit here more than 3 cycles, I have just fried this panel. Except if it's a switch gear. If you guys look at the switch gear is rated for 30 cycles. What does that mean? Meaning, if this has to be a switch gear, which never be, but say, suppose it's switch gear, I have a short circuit on this switch gear. The short circuit can sit there for 30 cycles. What's 30 cycles? 30 divided by 60 is half a second. Half a second. I can allow the short circuit to sit here for half a second. That's eternity in the short circuit language. Eternity. So half a second before this baby trips. Before this circuit breaker trips. Now, who cares about this? That allows you a lot of coordination, guys. Allows you to sit the main at 30 cycles, and downstream, guys, you will sit them at 20 cycles, 5 cycles, 3 cycles. So that will allow, if you have a short circuit on a 600 amp panel, it would never, and you have a switch gear, it would never take the 4,000 amp switch gear, ever. Because you allow the short circuit to sit for 30 cycles on the main panel, while in the panels underneath it, it has to trip within 3 cycles. So that allows a lot of good coordination, guys. Number one. Number two, they're rated for 30 cycles. So if you allow half a second short circuit sitting there, guys, 65,000 amp short circuit sitting in a panel and shaking that panel inside out and burning that panel, and the panel is still sitting there. That's where the ANSI rated panel comes to be. They're rated, they're insulated, they're robust, they're big, they can handle a 60, some of them, they can go up to 100,000 amp rating for them. 100,000 amp at 480. Short circuit for half a second, sitting there, cooking these equipments, and when you trips, you'll go there and nothing happens to any of these buses. circuit breakers are robust to handle it. So that's the single most important thing about switchgear. Really is the ability to handle a huge amount of short circuit without burning itself. Switch boards, by the way, they're 3 cycles. All these equipments here are 3 cycle equipment. Switch boards are 3 cycles. That's why you pay 25 to 30% more on a switch gear, even though they look alike, they do the same function. You pay 25 to 30% more money-wise if you are to specify switch gear. Any question, guys? So that's basically in terms of panels. Really, as an engineer and as a designer, that's what you need to be aware of. What you need to be aware of. When it comes to switch gears and switchboards, guys, Spencer, the circuit breaker no longer a 100 amp circuit breaker. So when you have a switch gear, switchboard, they don't just talk about 100 amp circuit breaker. They talk about frame size. You're going to hear them talk about the frame size of the circuit breaker, meaning the physical, mechanical dimension of the 1000 amp, the trip size, the sensor size, the trip size, and the sitting size of the circuit breaker. So every circuit breaker has 3 sizes when it comes to switch gear and switchboards, unlike these babies, which has only one size, 15 amps. So before I go to this one, I just want to highlight the sizes in a second. Any question, guys, about these? Does it make the big picture instead of getting into the details that Jim did a great job in the structure and how it's built and all this good stuff? As a designer, really, that's what we care about. What we care about. The amps and the voltages, so I can throw them in my buildings. What's the best application for this particular job? Mr. Bew, did you work with switchgear, switchboards? So, any question, guys? Any questions? So I'm gonna go to, if I can. Oh. Is the network slow today, or am I slow? My computer slow? What's going on here? I'm not used to slow equipment. Is your magnetic field around here, Muhammad, my friend? Or maybe because Holly is not here today. Okay, I just want to talk about, guys, power circuit breakers. We'll talk about them later on too. Only this is switch gear for the most part. Switch. Oh, come on. Brad, what did you do, buddy? Why is my equipment is hanging in there today? It's not Friday. Look at this. I really want to write these things. It's about to crash. Let's talk about this one, guys. There's something called sub-feed and feed-through. Do you guys remember what Todd Christensen last quarter said about sub-feed and feed-through? Sub-feed and feed-through, if you have a panel like this is called sub-feed. You come from the line side and feed another panel. So if I'm to draw, if I can draw, imagine this cable, guys, is 225 amp panel, 225 amp cable. You come over here to a 225 amp circuit breaker. You, from the line side, you'll have 2 lugs here. You have to have 2 lugs. 1 lug in, 1 lug out. In, out for each phase, and a neutral. Can you see the neutral here? And then you tap from the line side, go feed another panel, and a 3rd panel, and a 4th panel. Brad, this was big deal when they limit us for a 42 circuit breakers. It's no longer a big deal. Now because Spencer, my friend, and Brooks and Ryan, because we can go as high as 84 circuit breakers, feed through and sub feed it's not going to be a big deal. I can rack a 42 circuit breaker right now, an 84 circuit breaker in one panel. And you really don't want, from a reliability point of view, guys, you don't want to put more than 84 circuits in one feeder. Are you kidding me? If you lose a feeder, you're gonna trip 84 circuit breakers. That's as maximum as you can get. So, but because of the 42 limitation, like Jim said yesterday, they used to have 2 lugs here. I have my 225 amp panel. I ran out of I ran out of space here, guys. I have no space. So what they do is they tap from here and put another panel here, and another panel, and a 3rd panel. That's called sub-feed. Feed through, you guys remember what Todd, I think, did a great job with feed through. Feed through, Spencer, you bring the feeder in from this side, through the bus, out the other side. So that's what the feed through, they call it a feed through. Either one would work. And I said, it's not going to be a big of a deal.
Feed through and what?
The feed through, okay, here you go. I think I'm in.
Feed through, what was the name of the one?
Give me 1 second. Subfeed.
Huh?
Subfeed. Subfeed and feed through. Oh, I hate that. Oh, there you go. Subfeed and feed through. So here's a panel number 1, guys. Panel number 2. I can come up with a feeder in, feeder out, and a panel number 3, feeder out again. Each one of these is 225 amp. I have a circuit breaker 225 amp. The feeder here 225 amp. I have another circuit breaker 225 amp. And another circuit breaker here 225 amp. And a cable 225 amp. So I have a 225 amp feeder that feeds 3 panels. Why would you do something like this? In hospitals, well, not in hospital, but a good application for this, you ran out of 42. Remember the limitation on 42? I ran out of 42. I didn't run out of juice, just the space, physical space. Then you start racking these tubs, they call them tubs. That's kind of your feed through. And why do I put a circuit breaker here? Do I need a circuit breaker here? I don't. But if you don't put a circuit breaker here, guess what? Yeah, if you don't put a circuit breaker here, if something happened in this panel, you lost. There's an overcurrent protection device right here, 225 amp, right in this panel. If you don't put circuit breakers on them, which you don't have to, then each one of them will be. If you have a short circuit here or here or here, it will take the main. Do you really want that? So that's how they use the subfeed. This is called DJ, my friend. It's called sub feed. Now the feed through is the opposite. They come from here, guys, with a different log, and come from here and come from here. The same system. See how it's feed through, feed through, feed through. For feed through, you don't need a circuit breaker for feed through. You don't put a circuit breaker. So you're coming from here, as you can see, through a circuit breaker, and you really don't need a circuit breaker even here. You came from here, circuit breaker, and you subfeed with the same thing, 225 amp, and here is 225 amp, and each panel is 225 amp. I don't need a circuit breaker. You can if you want to. Well, actually, you can't. If you do a subfeed, they don't have, most of the time, they don't have room to put a circuit breaker for you because you're doing feed through. So the difference, guys, here's what the difference is. Can you guys see the current? The current here, look at the current here, goes in, and it doesn't, only the current that consumed by this goes into this panel. This panel only sees, if it's subfeed, the current that's consumed by it. If it's feed through, the current, look at the current is going to go through each and every one of them, right? So if I have a lighting fixture here, the current that's feeding this lighting fixture is actually seen by each and every one of these panels. Each and every one of these panels. So they have to be the same size, basically. Anyway, the concept of feed through subfeed, guys, as I anticipate with the 2008, you can rack as many as 84. It's not going to be a big of a deal for the new. Any question, guys? Subfeed, feed through, Mr. Bab? Subfeed, feed through. It's not a reliable system to subfeed, feed through. The best reliable system, guys, is to have a feeder, 1 feeder per panel. That's the best reliable system. What's the problem with this? Expensive. But with the 2008, guys, you can do it because you can have 1 feeder, 225 amp panel, a circuit breaker feeding a feeder to a panel that goes from here all the way to the bottom with 84 circuit breakers in it. That's good. That's good system. You can feed a lot of stuff from an 84 circuit breakers. So that's what I wanted to talk, guys, about these. One thing I want to talk about the power circuit breakers, which we will come. Switch gear. If you have a switch gear or switchboard, this is mainly for switch gear, switchboard. Let me give you an example. Here is a circuit breaker, and the circuit breaker is 4,000 amp. I have a circuit breaker 4,000 amp. They have three sizes for the circuit. It's not enough, Spencer, to say I have a 4,000 amp circuit breaker. That's meaningless. You're going to say the following. You're going to find each one of them has three sizes. 4,000 amp circuit breaker. Number one is frame size 4,000. Frame size. Now, what is the frame size? Frame size is how big physical location space I need for the circuit breaker. That big. And most of the time, guys, a 3,000 and a 4,000 amp circuit breakers fit in the same slot. So the frame size is 4,000, meaning I can fit up to 4,000 amp in this slot. Okay, that's just the physical size. The second one is frame sensor, or they call it, yeah, sensor. Let's go sensor. Sensor size. Sensor size. Anybody can guess what the sensor size? It's the CT. They have CTs, guys, with the circuit breaker. What size CT do you want to put in the circuit breaker? What size CT you going to put in it? So I have a 4,000 amp. You know what? My load is actually, I'm going to put a sensor on this one, a 3,000 amp sensor. Now I'm limiting a space, a physical space, 4,000 into now a sensing of 3,000. That's my sensing. I'm sensing at 3,000. Then trip unit, and we're coming to this, guys, when we do over computation coordination, becomes a big deal. Trip unit, I'm going to go trip the 3,000, this baby 3,000, I'm going to go trip it at 2,000. My trip unit, you know what the trip unit is, guys? A tiny little device at the face of the switchgear that you can change. You can really change it. So I can buy, there's a plug, right? A plug, actually, trip unit or a plug. In the face of the switchgear, I can go plug a 2,000 or a plug a 3,000 or a plug a 4,000 right in the face of the circuit breaker. The face of the circuit breaker has a hole, guys. They can plug a plug-in unit in it. So my trip unit is 2,000. Look how we went from 4,000 to 3,000 to 2,000. Now it even gets more. Now I need trip unit. I need setting. It's called long time pickup, and I'll talk about the only important setting is, guys, a long time pickup. Long time pickup, Mr. Rabab, my long time pickup on this circuit breaker, I want to make my long time pickup 0.8. I'm going to set this one at 0.8. What's 0.8 of 2,000, guys? So 800 plus 800, 1,600. So I'm going to set this baby at 1,600. See how when you go into the power circuit breakers, every circuit breaker has actually 4 when you count the plug-in unit, 4 settings for the same circuit breaker. Here's the physical mechanical frame. Here's the CT. This is the CT, the physical frame. This is the CT. This is the trip unit that you can plug in, change it. And this is the actual circuit breaker. Now, my question for you, Jim, my friend, everybody else is, now when I size cable for this circuit breaker, which amps should I use? Right? You need to size cable. Which amp should you use to size? Should I use the 4,000, the 3,000, the 2,000, or the 1,600? When it comes to the trip, we size cables exactly based on the setting, guys. So when my cables, this is very important. Size feeder based on long time pickup, which is 1,600 amp. So Brad, for all practical reasons, that circuit breaker that you're looking at, in reality, it acts like a circuit breaker here with 1,600 amp. When I size the cables, I size based on 1,600 amps. The question, DJ, becomes: what if a wacko guy goes and reset this circuit breaker, right? Up it from 0.8 to 0.9. Now you increase the size. Well, usually these guys are under closed doors and supervised and so forth. But the code allows you to size the cable, Mr. Abel, directly based on the size feeder based on the long time pickup. We're coming with the software called SKM, guys. As KM software, you're going to hear Chet talk about long time pickup, short time delay, and so forth. So this is only with what we call them adjustable electronic circuit breakers. Not with these ones. These are dumber than rocks here. They don't do that. These function. They're small. These are with adjustable electronic circuit breaker. Big circuit breaker with electronic equipments, sensors and so forth, and a brain. I don't know if you guys remember last night Jim was talking about how you can talk to these circuit breakers and collect data from them. These are the circuit breakers that we're talking about. As designers, we don't get involved in guys networking them and all this good stuff. I guess you can go that route, but we get involved all the time in a 4,000 amp frame that I want to trip it at 1,600 amp. Why would you do something that, by the way? Why would anybody do something like that? In the future, I can change the plug, the sensor here, go there, change the sensor to 4,000 amp, change the trip unit to a 4,000 amp, change the setting to 1, that will give me 4,000 amp. The same circuit breaker becomes a 4,000 amp circuit breaker. Just by changing, it probably will take you, shut it down, probably 20 minutes to do all these changes. Especially the sensor, you need to shut down. The plug-in, guys, see that trip plug-in? The plug-in, I can go up to 3, I can change this one to 300 amps and the setting to 1, which give me, I can make this 1,600 amp circuit breaker, 3,000 amp circuit breaker in literally 1 minute. By unplugging the sensor here, the trip unit, and I have another trip unit that plugs right into a 3,000 amp plug unit, and go to the setting right in front of it with a screwdriver and unscrew it from 0.8, like I said, it all the way to 1. Now I can change within a minute. I can change this 1,600 amp circuit breaker into a 3,000 amp circuit breaker.
Then you have to run your cable.
Thank you. Yep. If you do that, then you have to change. You have to run new cable.
So I challenge you 20 minutes on that.
Yeah. 20 minutes a circuit breaker, but yeah. But running cables is a different story. Yeah. You have to run new cables. Why would they do something like this, guys? Because at the higher amp, it's really nice to have the flexibility to get you different amps. Now, I always told you guys to size the actual standard circuit breakers 240.4. 240.4, if you go to 240.4 DJ, and Mr. Rabab, you go to 240.4, right underneath the table, I don't know how many of you guys have paid attention to this, it says non-adjustable circuit breakers and fuses. The sizes that you get 15, 20, 25, 30, Mr. Buell, it's directly for non-adjustable circuit breakers. Right under that table. If it's an adjustable circuit breakers, where are you going to go? To your friend Chad and yourself, guys. You're going to go to the manufacturer's sitting. You are going to be sitting these circuit breakers. With hospitals like Mayo Clinic that we did, we do all these sittings, guys. You're going to be doing it as a designer. Come up with from a 4,000 amp frame to a 1,600 amp, and you give the sittings to the electricians and go size your conductors based on the 1,600 amp. That's why we have electronic circuit breaker, because you can tweak them. You can tweak them down, and you can get much more than what 240.6 can give you, Mr. Rabab and Muhammad, my friend. Any question, guys, about this? So I thought this is, every time, Spencer, you think switchgear, switchboard, always think this type of circuit breakers. That's why we have switchgear, switchboard. The reason why we have it, the adjustability for them. It wouldn't make a whole lot of sense to use they call them molded case circuit breakers, non-electronics with switchgear, switchboard. That doesn't make sense. Electronic circuit breaker make a lot of sense, guys, at 1,000 amp and higher. 1,000 amp and higher makes a lot of sense to use electronic circuit breaker, which you can tweak. I can tweak a 1,000 amp electronic circuit breaker to pick up 50 amps with sensors and plug-in. I can make a 1,000 amp circuit breaker, guys, pick up 100 or 50 amps by changing the trip, changing the sensing, and all this stuff all the way to 50 amps. Or even 55 amps, by the way. There's no circuit breaker 55. You know what I mean? I can make a 55 amp circuit breaker through the settings. Okay, any question, guys? Any question about that? So that's what I thought, just to mention about these. I want to bring to your attention, and I know I picked on my friend, who's my friend today? Can you guys remind me of my friend? Not DJ, Brooks. In his presentation, I picked on Brooks when we talked about the panels, guys. One thing I want to make sure when we size panels, there is a difference between the size of the panel and the size of the overcam protection device in the panel. Most of the time they're the same, guys, but these are two different things. For example, let me tell you that I have we always go by the load. So suppose, just quick here, suppose the load in this panel was, I'm just going to try to use something, a smart alecky here. Suppose the load was, let's say my load was 431 amps. I calculated the load from this panel and it was 431 amps. Okay, now I need to go size a panel for it. If you guys go to 3.12, it will get you the next standard panel that I can get 600. This panel, right? This panel right here, panel size, it's going to be the next standard 600. Okay, so I have my 600, right? Can you guys see that one? 310.12, 600. Now my overcam detection device, 310.13, based on the load, 431, which I already took into consideration future expansion and all this good stuff. If you guys go to that one, I would have 450. So my overcam detection device would be 450 amp. And what do you guys think the conductor is going to be? Match the overcam detection device, 450. Okay, so I can have a 600 amp panel fed from a 450 circuit breaker, broken at 450 circuit breaker, and the cable have to match the overcam detection device. Okay, is it wrong to make the circuit breaker 600, then the cable have to be 600? No, but what's the issue with that? Money. And we talked about this one, guys, from 10 to 15% if you're around, go up. But this is judgment, I guess. If I was close to 600, I will use 600. I'm way far away from 600, right? Based on my load. And guess what? My load, Spencer, already taken into consideration 10-15% future expansion, right? You have to think about this one. Have I taken future expansion in consideration? Yes, Chad, I already took future expansion. And I came up with 431 amps after I applied this future expansion. Should I go to 600 also? That would be overkilling. Any question, guys? See how the panel, you have the size of the panel, the size of the overcam detection device, and the size of the cable. And the panel and the overcam detection device do not have to be the same size. Here's my question for you guys. Can I put an 800 amp circuit breaker here on a 600 amp panel? No. So the overcam detection device must be equal, Mr. Rebab, or less to the overcam detection device. Why? Because if you put an 800 amp circuit breaker on the 600 amp panel, you're going to burn that panel. You're going to overload this panel. But I can put less.
What did you go to 450?
450. This is Mr. Rebab from, this number, guys, came from 240.6. This number came from DeWalt 3-12. Thank you. 3-12. Any question, my friends? Any question about the panel size versus the overcam detection device size? Panel size versus overcam detection device size. Yes, Mr. Bell?
Yeah, sure.
You can't scratch your ear here. It's an auction here.
No question.
I wanted to say one little thing, guys, about the MCC, and then I want you guys to write. I don't know if I gave you these sizes. By the way, next week we're going to do sizing MCCs. We're going to do one of the sizes that we're going to do MCCs. So please do the following sizes for me. I picked them up from Cutler Hammer. They might not be the typical for all of them. MCC typical sizes. MCC typical sizes. Okay. Here's the sizes that I have, guys. Add them. I added them to. Here's why I put them. I always put them in 3-13, guys. 3-13. So I have 400, 600, 800 standard sizes, and then 1200, 1400, I believe, 1400, 1600, 1600, 2000, 2000, and 2500, 2500, 3200, and 4 grand. 4,000. These are typical standard MCC sizes. Please don't hold me accountable. Some manufacturers use slightly different, but for the most part, if you're looking for an MCC, they're similar to the panels, but slightly different. These are the typical started for MCCs. What is an MCC? Motor Control Center. The single most important thing about MCC, guys, is the starter. I hope you picked up yesterday when my friend was talking about it. Here's what an MCC has that a panel doesn't have. You guys remember the overcome detection device? You guys remember the controller? Remember the overload? And what else do we have? No, this is not an overload, Chad. The overload, there you go. Overload. So I have the overcome detection device, the controller, the overload. Am I missing something here? And from here to, I'm just going to show quick, guys, the control circuit, the push buttons. You guys remember that push button, start, and the push button, stop. All these, and the contact across these, and okay, what else? And low the low voltage. I mean the overload. So here's what a bucket. He was talking about buckets yesterday. Here's what a bucket looks like, guys. A bucket looks like this. All this stuff in one bucket. See how? If you guys open this panel, would you see a contactor in that panel? You see the overhead. This is suppose this is a 225 amp. Well, let's make it more realistic. Let's say this one was a 50 amp overcome detection device. Here's a NEMA. Remember NEMA standard, guys, contactor, overload, the control circuit, all in one big bucket. And you can push buttons, guys. The push button, start, stop. Lights, they have some lights on the bucket. So when you draw that bucket, it has a disconnect in it, which is overcome detection device. It has a contactor, a push button, start, stop, and some lights all in one big bucket. Now to fit this one, depending on the size, guys, you're looking for a good size. You're looking at a foot by a foot by a foot, really, space for a good size NEMA for starter. Any question, guys, about this? This one acts as one big bucket inside this MCC. I'm going to erase these and just draw a typical MCC and how the size is. Very typical, guys, if you ever got into an MCC situation. How do we size them? Brad, my friend, exactly based on the full load current of the motors. The largest motor multiplied by 1.25 plus all the other motors, and we size them based on these standard sizes. Here's a typical MCC. Typical MCC, guys, is going to have, for the one bucket is going to have 1, it's going to have 2, 3, 4, 5, 6, I believe. You can fit up to 6 of them in one MCC. So you can feed up to 6 motors, buckets. They count buckets, 6 motors with a starter from one MCC for the most part. And some of them are smaller motors, 30 horsepower or less. So that will be pump -1, and this will be air handling unit -1. This is recirculating pump -2. This will be condensing unit -1. This will be pump -5, and this will be air conditioning -3. And that's how you, on the face of one big panel, what is it, 92 inches high, what is it, 20 inches wide, deep, he said 13, you can get them 13 or higher than that one. You can see an MCC. So you can draw this MCC, guys, out, take it, put it on the table, fix it, mechanically fix it, change the contacts in it. And while you're changing it, you don't want the air handling unit to be off. So you have a spare one just sitting for this. You plug it in while you're changing the contactor, mostly the contactor, changing the overload, adjusting the contacts. So that's advantage of an MCC. Where would you use an MCC? Process control. Any area that need a process control, guys, manufacturing process control, a big deal on them. I've seen it personally in not data centers, what we call them, wastewater treatment plants. They love them. They love them in wastewater treatment plants. They actually make them a service entrance equipment. All what you have is just big MCC that's 12 foot wide, and they bring the service to one section to it with 1200 amp disconnect, and then the whole section is an MCC. The whole section is an MCC. I don't know if you guys picked up yesterday also, in a case like this, what they do in wastewater treatment plants, they make a receptacle panel here, and they feed from this bucket, they feed a panel, a transformer first, and from a transformer, they feed another panel, which is receptacle panel. In a case like wastewater treatment plants, you have to have a receptacle panel. You can't have, I can feed everything from 480 to 77 except what? Convener receptacles. I can feed light from 480 to 77, but I can't feed receptacles, unfortunately. So what they do is they steal one bucket with 100 amp, just 100 amp circuit breaker. This one would be only the circuit breaker. It doesn't have all the stuff in it. And they go feed it to the panel, and now I have a panel that feed all my receptacle, 100 amp panel or 225 amp panel. Any question, guys, about the panels? I thought between what Jim did yesterday, guys, and what I did today, hopefully that will give you an understanding of panels. As Eric, as designers, all what we deal with panels every time. MCC, switchgear, switchboard, panels, load centers. So I hope, guys, that will be very clear in your mind how to size them. We're going to take a few examples how to size them. I promise you, we're going to be taking how to match a transformer to a receptacle panel. I haven't done that. What transformer goes with receptacle panel? You guys are going to be sizing this. That's coming next week. How do you match a transformer to a receptacle panel?
We're doing that for our project.
We're going to do that. Yes, we have our project too. We have receptacle panel, don't we? Did they say two?
Well, there's a couple of panels that you have to feed out of it, feed 120.
Oh, there's a bus duct. Yeah, 28120 bus ducts. The same thing. How are you going to match a receptacle panel transformer to the bus duct? Just give you a hint, guys. We size the transformer based on the load. Go KVA, find what's your KVA, and then go to the next standard KVA and try to match, Camille, my friend, try to match the panel to the full load current of the transformer on the secondary side. Any question, guys, about the MCCs, load centers, panel boards, switchgear, switchboards? Did I make your brain spin or no? If you read the Article 408, Mr. Bew, if you want to go to the Article 408, you wouldn't find all this information that we went over. You wouldn't find half of it. The NEC code does say 408 panel boards. It treats all of them as one lump sum. The load center, the switchgear, switchboard, power panel boards, all of them are treated as panel boards. The only thing you need to understand when you go to this center, guys, is to this article is, number one, you have to have an overcome protection device for every panel. You have to. That could be inside the panel or outside the panel. They tell you that. And the overcome protection device have to match the panel or be smaller. It can't be, the overcome protection device cannot be more than what the panel is rated for. So that's basic, and a couple of things about structure, how to build it. If you have space openings in the panel, you have to cover them. And as we know, you can't, for example, if you have a slot here that's not used in the panel, the code says you have to go cover this slot with an equivalent steel. A cover, steel cover with an equivalent to the steel structure of that building, of the panel. But it doesn't tell you how to size them in any NEC code book, nothing. It just... Any question, my friends? I want to emphasize, guys, in panels, you can have single pole circuit breaker, 2-pole circuit breaker, 3-pole. 99% of what you guys are going to be installing in commercial industrial is going to be 3-pole circuit breaker, except, anybody can tell me where we use single pole circuit breakers? We could, receptacles and lights. And even receptacles and lights, Eric, my friend, with a multi-wire branch circuit right now, they have to either be a 3-pole circuit breaker, one big circuit breaker, or 3 circuit breakers tied together, Gem, with an approved handle. If it's a multi-wire branch circuit, which you should use multi-wire, that's to save a lot of money. So a standalone circuit breaker, it's becoming so hard to find one because you're always using multi-wire branch circuit tying the 3 together. MCC, I have never seen an MCC with a single pole circuit breaker, or even two pole circuit breaker. You would never. I mean, it doesn't pay to have an MCC with less than 3 pole circuit breakers. It just doesn't pay. They don't. If you have an MCC, most likely you have a 3-phase system, and you wouldn't use a single phase, 2-pole or 1-pole.
It's, 3-pole means 3 phase.
Yeah, 3-pole means 3 phase. Yep, Mr. Bill. Any question, guys, about the panel? So that's basically what we, for those of us who are like Mr. Bu electricians and DJ, you guys know that you can't land 2 cables under 1 lug unless the lug is rated for 2 cables. That becomes more installation. So if I have 2 cables and I want to land them on a circuit breaker, I need 2 lugs, 1 lug for each cable. If I have 5 cables coming to 1 circuit breaker, why would I do that, Mr. Bell? Parallel. If you're paralleling 5 conductors to carry 1600 amp, right? You're going to land them at the terminals of the circuit breaker. Here's 5, so you have to have 5 lugs, 5 cables, lug per cable, 1 lug per cable. So you can't put 2 cables under 1 lug unless it's rated for. With most of the time, guys, especially in these equipment, a lug per cable, a lug per cable.
Is that in the code?
Yes.
In the what?
310.12, I want to say. 310.12. So, and also to 408. 408 will tell you that. 408. Any question, guys? That's all I have, my friends. I just want to quickly remind you that we have the trip tomorrow, and I would like you guys to print work on your. I'll be around. We don't have any speakers or anything, so I want to be around. I don't even eat anymore, Mr. Beb. I just gave up food for you guys. And
You're saving more.
saving money. So I just want to quickly remind you guys that with the trip tomorrow, we're going to meet at 9 o'clock sharp. They have security people. I want to, I don't know how anybody have been there, guys, in that area. If you have been there, it's a campus like the U of M. Well, a little bit like the U of M. So there are multiple buildings. You're going to park, the parking lots are huge. So you can park anywhere in the visitors area, a huge parking lot. And you have to walk, probably for DJ, probably will take you half an hour. For me, it will take me 25 minutes. You're going to walk at least 5-10 minutes, guys, in the parking lot. And then make sure you go to the building in the middle. So there's 1, 2, 3, 4, I think. So go 1, as you enter, don't go to the first one, go to the second one. If you go to the first one by mistake, they'll send you to the second one anyway. To the one in the middle, which is the second one. Okay? Any question, guys, about the trap? So I would like you guys to work on the low voltage, if you can, so you can print it for the A students. And the B. Okay, thank you, guys. That's all I have. Next week, just if anybody wants to plan accordingly, we're going to have our first test, which would be in the first chapter, 5 chapters, which we covered. And the first 5 chapters, guys, and calculation, I'll tell you the calculation next week. So most likely it's going to be Thursday or Friday, our test. Thank you, go eat. If it listens to me.
What did he say?
If it listens to me, it's not responding. It's not